masses 200 grams and 400 grams and place at these position 8 centimeter and 4 centimeter respectively on the two sides. So it is a correct position to choose that the total momentum acting on this is zero. 400 multiply with 4, the torque, the moment of the force, the weight on the left, equal to the other clockwise moment, 200 times 8. I didn't multiply with 10, meaning converting the mass. Of course, if we want to calculate the moment, we have to convert the mass from gram to kilogram first, and then multiply with 9.8 or 10 to calculate the mass. But basically, that products 400 multiplied with 4 equal 200 multiplied with 8. It is the correct option. Okay. Equivalent 400 gram equivalent to 4 newtons. Okay, acceptable. With G taken as 10, 200 equivalent to 2 newton. Equivalent, not 4 newton. Okay. So if you do the test, the questions calculate the explain how you would test that your chosen massive give no net force to the disk. Question B, You cannot write like this because the mass in gram cannot be equal. The same thing with the Newton, okay? Really like the short answer, writing like a note for yourself only. But when you write like this in a real test, they will subtract the mass, the mark, okay? Question B, explain how you would test that your chosen massive give no net moment to the disk to be, okay, equal to 4 Newton. Again, you can say the mass of the weight of the 400 gram mass, or the 400 gram weight, 400 grams weight, 4 newtons, and similarly 200 grams weighs 2 newtons. The moment due to the first mass, you can add some more detail in the clockwise direction. First mass counterclockwise on the left, counterclockwise, and the other moment in the clockwise direction, they are the same. You need to use another conclusion, The two moments counterclockwise are the same, okay? Because it's just the work, the calculation, but not yet the conclusion, okay? The two moments are the same in magnitude but opposite direction, cancel each other out, or the total moment. Therefore, the total moment is zero. Okay, moment is very similar to vector like forces. Actually, in your current level, you do not study moment as a vector, and even in A level, but some advanced level, like in the university, moment is actually a vector, and therefore they cancel out when they are in two opposite direction. Okay, so the total moment is zero. Or you can say they cancel each other out. Okay, due to second mass, and you also need to mention their direction to show that they will cancel each other out. It is not enough like there are 2 marks of this question and you get only 1 mark. Okay, be more careful with the solution, not just like to get the result without the detailed explanation. Okay, question C, calculate the moment about the pivot due to the 2 masses chosen. Okay, done. When you put on, explain how you could test the chosen mass given nominate on a disk. Okay, question B, answer like that, acceptable. This does not turn or rotate. Okay, C, correct. D, Calculate the force on the pivot when two masses are chosen hanging from the disk. Again, I just explained earlier, okay, the condition for equilibrium of an object. No movement to left or to right in any direction. We call that translational linear motion. And also no rotation. When the two conditions are satisfied, the first thing is the net force, the total force is 0. Okay, and second thing is the total torque. Torque is also 0. So on the pivot, there are two forces downward acting here, 4 Newton and 2 Newton on the right. Okay, the force on the pivot is simply in the opposite direction and equal to the sum of those two forces. The force here on the pivot is 4 Newton added with 2 Newtons. Okay, 6 Newtons, simply that. So that is the answer of the question D. Okay, you can answer the force on the pivot is 4 Newton added with 2 Newton equals 6 Newton, and mention the upward direction. Okay, upward. The total force before that, the explanation. Okay, the total force on the disk is 0. On the stationary disk, totally no movement at all, no linear movement, and no rotation. The total force on the stationary disk is 0, So this is the simplify the short explanation. Okay, the first sentence is the reason, the explanation. Okay, let's see the mark scheme here. Question D, No, there's no answer for question D. That's weird. D. Wait, it's probably the wrong answer, Wrong answer. This is not the answer, but this is forces. Paper. Mark scheme here. Yeah, there's something wrong, but okay. Continue with question 4 here. Increases as well. Direction movement, the model car, circular track, acts on the car to keep it moving in circle, draw an arrow to show direction of this force. Moving in circle. They didn't say anything about the speed of the car. Does it change, increase, decrease, or remain the same, The force, okay, but because they didn't say that, we have to assume the simplest case is that the speed does not change, only the direction of movement, direction of velocity. Okay, and you drew it correctly, the direction of the force, which is centrifugal force. The speed the car increases, state what happens to the magnitude of this force. It must increases as well. Good answer, that's correct. Let me check if there's an equation given in the booklet here, about that centrifugal force. And I see no. Oh, here it is. Okay. The centrifugal force is calculated by mv squared over r. Okay. This equation. Centrifugal force. So we see that the centrifugal force here is proportional to the square of velocity. And therefore, when increasing the speed, the centrifugal force will also increase. Double the speed, the centrifugal force will be 4 times greater. Okay. So correct answer. Question B. In terms of the forces acting on the car, suggest why it left the track at P. The car travels too quickly and leaves the track at P. Draw an arrow to show the direction of the travel after it has left the track. Okay. You didn't draw that? Okay, here. The point is that the direction of movement must be tangent to the circle, which means perpendicular to the radius there, huh? You need to draw an arrow so that it is perpendicular to this radius. Okay, so this vector that you drew was not very accurate. Okay.
Okay.
Fix that. Yeah, fix that on your notebook. Erase this one and draw the new one. Emphasizing that it's a right angle to the radius here, meaning tangent to the track. This is the velocity when it leaves the track, tangent to the track, meaning perpendicular with the radius. In terms of the forces acting on the car, suggest why it left the track at P, because the forces that keeps the car moving in circle will be less than the speed of the car. No, you cannot compare a force with a speed, huh? Like you cannot compare a person with an elephant. They are two different things. Okay, you were almost correct. The force that keeps the car in this case is the friction, huh? This is just additional information, okay? Friction or some partly the normal force if the track is tilted. Những cái đoạn đường cong người ta sẽ làm cho mạch đường nó bị cong, nó bị nghiêng một góc đó con. Mạch đường nghiêng để làm gì? Khi mà mạch đường nghiêng nó sẽ tạo ra một cái support, một cái normal force của nó này. Sẽ có một cái component của normal force nó hướng vào tâm của cái đường cong. A component of the normal force will point toward the center of the curve, and therefore it will add to the friction, increasing the centrifugal force and help keeping the car from sliding away from the track. Huh? So it is safer when you're turning like on a road on a hill or mountain, huh? Mountain road, where the road is tilted, huh? An angle. It is better to make a row like that instead of a flat horizontal row, huh? So to keep the car moving circle will be less than, or we can say will be not enough anymore, huh? To keep it from from moving away due to its inertia, huh? Yeah, we can say that. Will be not enough anymore to keep the car from moving away because of its inertia, huh? Away from the center because of its inertia. The force that requires to keep the car in the circular motion will be calculated by mv squared over r, and this force is now greater than the friction, huh? Yeah, so it's lightweight. We can see that with some video about car racing, huh? Or bike racing. Yeah, but those things are dangerous for attendance, for people, you know, doing the race, huh? Car racing, for example, accident, it could be, but many people do that thing, the race, the competition, because of the high price, huh? And the excitement when, you know, running with high speed. Okay, question C here. We have a graph describe the motion between 3 and 10 seconds after the car has started. 3 seconds here, huh? So it increases the speed linearly, constant acceleration, and then remain the speed for the last 7 seconds, huh? Okay, and your answer, the moment way. Okay, question C. Okay, describe the motion between 3 seconds and 10 seconds. Yeah, that is constant motion with a speed of 25 centimeters per second. Constant speed. Okay, you should mention also the value of the speed there, huh? 25 centimeters per second. calculate the circumference of the track 25 divided by 3. Why? Y divided by 3. Complete one lap in 10 seconds. Okay. The way to answer this question, the circumference of the track, is actually the total distance that this car traveled in 10 seconds, not only in the last 7 seconds. Okay. And that distance that the car traveled is calculated by the area under this speed versus time graph, which means the area of this trapezoid. Okay. Please fix your answer.
Okay.
It is the area under that trapezoid. Let me plot again. This area. The distance, the length of the track is the distance that the car travels in 10 seconds. Because it's only one mark and we have only one row, so we need to calculate the area of this trapezoid. That distance, the length of the track, is 1/2 of the big space. Big space here, which is 10 seconds. Okay, add it with the small base here. Small base is how many? 7. 7 from 3 seconds here to 10 seconds. That's 7 seconds. And the height of this car is this trapezoid. The height is 25 centimeters per second, but you have to divide 100 to convert the speed from centimeter per second to meter per second, and we will get the length of the track in meter, not in centimeter. Okay.
But why in meter? Why in meter, not centimeter?
If it's centimeter, the speed, we need to divide 100 to convert into meter, so that the length, the distance that we calculate will be in meter. Okay.
But why? We cannot calculate it in meter. Centimeter. We cannot calculate the.
Why not? The speed is 25 centimeters per second. Speed, okay. We can simply convert 25 centimeters by dividing it with 100, meaning 0.25 meter per second, and multiplying this speed with the time, which is second. The speed is
why
not
cannot we calculate the?
Calculate
why
what?
cannot we calculate the track in centimeter?
Yes, it is can be in centimeter without a conversion, but it's not the standard unit, and the answer is question 4, not question 5, right? Wait. Question 4. Okay. They didn't provide the unit, the required unit for these questions. So normally we will use the standard unit, or I think it is acceptable also to use centimeter, but I prefer using the standard unit. Okay.
Okay.
17 multiplied with 25 divide 100. The track is only 2.1 or 2.2 if we round it up to significant figures. Meter, that's weird. That's like it's a toy, not a real car, Is there some error in this problem? Because it is like a tiny, you track how this is a car, a toy car, not a model car, toy car, not a real car. Okay, and weirdly, there's no answer for these questions. Right. The distance. This is question C1. Okay, here. This is in centimeter. Okay, so they didn't do the conversion to meter, Yeah. Any value, but no more than 2 significant figures, Yeah, so I rounded to the 2 significant figure. Oh, that is circumference. The answer is here, not this row.
Okay.
And we can say one more sentence, that is the area, the total distance, the length of the track is the distance that the car travel in one cycle, 10 seconds. Seconds. Okay. Which is 2.2 meter. Calculate the increasing speed per second during the time from 0 to 3. (25) divided by 3. The increasing speed per second. Okay. The whole phrase, the increase in speed per second, the long phrase here means the acceleration. Okay. So that acceleration is the final speed minus the initial speed divided by the time. Final speed is 25, initial speed is 0, the time is 3. So you did it correctly. Okay, well done. But I just want to emphasize that the whole long phrase, noun phrase here is the acceleration. Okay, and the result must be rounded to 2 significant figure, which is 8.3, and don't forget the unit meter per second square. Okay. Yeah, centimeter per second square. Good job. Question 5. The way W, the pivot, the force on the steam. Explain in terms of moment the forces, how the valves work. The moment the steam, what is this? Winds? Is greater. You should use the word simply like is greater, huh? Is or overcome. Is greater than the moment of the weight. Okay. Greater than the moment of weight in opposite direction also, huh? So the steam lifts the weight. Need to be a little bit more careful with the writing, huh? The weight W and allows the steam to escape. Okay. With the moment the way, so the steam lifts the way. Okay, okay, acceptable. Good answer. The moment up the way down or in the anti-clockwise is less than the moment of the steam, huh? In the clockwise direction. Moment of the way about the pivot is 12 Newton meter. The perpendicular distance of the line of action of the force of the steam on the valves on the pivot is 0.2. The area of the piston is this. Calculate the minimum steam force needed for the steam to escape. Okay. The force needs to be at least 61. You divide the torque by the distance. This is the force of the way, huh? Wait. Yeah, this is the force of the weight. This is the weight. 60 Newton is the weight, huh? The moment. Wait. Sorry. This is not the weight. This is the force, huh? It's the force needed to beat. Okay, beat. It's the force, huh? The force needed for the steam to push it up, huh? To push up, to push the lift up. What's it called here? This thing, the valves, huh? To push the valves up. Okay, to beat the weight moment. Okay, and divide that force. You wrote 60 here, but you use the value 61. Okay, and round it to the two significant figure, huh? You can write 0.2 times 10 to the power of 5. Okay, Newton per meter square. You don't need to take that many numbers. We learned the significant figure already. Okay, apply what we learned. Significant figure. Okay.
Okay.
Anyway, good job, and please fix that and send me the picture. Just want to make sure you're writing. And I will find another some other exercises. Paper 5 here. Moment, force. Slow. Okay. I think you can do the question 1 here pretty easily. So please move directly to the question 2 here, huh? Because it's harder. Yeah, we need to practice with this one. After fixing, writing some more additional information about this problem on your notebook, click on the link that I have just sent you and answer question 2 on that link.
Okay. Question 2 on the new link.
Draw a scale diagram for the forces T1, T2. 6 Newton, 8 Newton. You can choose like 3 centimeters for 6 Newton and 4 centimeters for 8 Newtons. Huh? And use the protractor to ensure the angle between these forces 69 and 44 degrees.